In this video we're going to see the coefficient rule in differentiation concept. Okay, so to start with, let us consider there is a ratio of functions f of x over g of x, and let us assume g of x is not equal to 0. Okay, it's not 0. In that case, what is the derivative d by dx of the ratio of these two functions, which is f of x over g of x? What is this? So we're going to use the basic formula, okay, the definition formula of derivative of a function, and use that to show the resultant of this particular equation derivation, okay, or the ratio of the function's derivation. So if we write that equation, the basic one, where we can write it like this, okay, limit del x tends to 0, f of x plus del x, okay, over g of x plus del x. This is like for this whole function substituting x plus del x in place of x, minus f of x over g of x whole divided by del x. Now we can rewrite this as by multiplying g of x with f of x plus del x and g of x plus del x with f of x, and these two multiplying, okay, it will come to the denominator and multiplied with del x. If you rewrite that with limit del x tends to 0, okay, f of x plus del x times g of x minus g of x plus del x times f of x whole divided by del x times g of x times g of x plus del x. Now in the next step, we're going to add two terms to this particular equation in the numerator. Okay, let us see what they are. Let me write down the same equation again here. In the numerator, I'm going to add g of x times f of x and subtract the same function g of x times f of x. Okay, so these two equations are equivalent and they are same. Okay, now taking this equation, we can rewrite this like by taking these two terms, the first one and the third one, okay, we can write by taking g of x as common. Okay, let me rewrite this. Oops. Okay, now we can take f of x plus del x minus f of x, and we are taking common g of x, and we can consider this function as well, this second term, okay, and the third term. So if you take that, let's take minus sign common in both these second and third terms. In that case, we will have g of x plus del x, okay, minus g of x, and we take f of x out of these two terms, which is common. Okay, and in the denominator we can write the same term here, del x times g of x times g of x plus del x. So if you take some space down, okay, and we can rewrite this by taking this del x onto the top. In that case, we can write limit del x tends to 0, okay, f of x plus del x minus f of x times g of x, okay, this divided by del x minus g of x plus del x minus g of x times f of x over del x whole divided by, we have these two, g of x times g of x plus del x functions. Okay, so now by looking at this, if we apply this limit del x tends to 0, this whole term here, okay, this term will be equal to d by dx of f of x, which also can be written as f dash of x. This is g of x minus, if you apply the limit to this particular term here, it will become g dash of x, or d by dx of g of x, and this is f of x. So product of derivative of g of x times f of x. So if you look at the terms below, if you apply del x tending to 0, it will become g of x itself. So we'll have g of x square. So let me rewrite this. We can rewrite this as limit del x tends to 0. Okay, if you apply that to the above function, we will get some resultant function. So I'm going to write the resultant one. Let me rub this off. So we'll have this equation equals to f dash of x, which is representing this term, times g of x, okay, minus g dash of x, which represents this particular term here, times f of x whole divided by g of x square. Okay, this is equal to, this is the equivalent expression for this formula. Okay, for this expression, d by dx of f of x by g of x, okay, is equal to f dash of x times g of x minus g dash of x times f of x divided by g of x square. To say these dash on f and g represents the derivative of that particular function. Okay, so this is the proof of this particular formula. Okay, thank you for watching.